July 28th. A Saturn 1B rocket stood ready at Pad B of Complex 39 to launch the second crew of Skylab astronauts on their space voyage. The commander of the second Skylab crew was Alan Bean, a veteran astronaut who had walked on the moon during the Apollo 12 mission in 1969. Dr. Owen Garriott was science pilot for the mission. Jack Lousma was pilot. The three astronauts would spend 59 days, almost 2 months, working and living aboard the Sky Laboratory.
We're right on the threshold of really a brand new opportunity to explore the solar system and the universe and to increase the value of benefits back here on home.
If our children and our children's children are going to enjoy the same quality of life here on Earth as we have enjoyed in the past, we're going to have to learn how to find new resources and how to manage the ones that we have more efficiently and more effectively.
And of course, space exploration provides this spiritual quality. It allows you to go to the unknown and find what's there, and hopefully by doing so, you're going to improve your lot.
About 3 hours before liftoff, the astronauts entered the command service module, which would carry them to and from the orbital workshop. An early morning launch was dictated by the orbital position of the space station and the time at which it would pass over Kennedy Space Center. The countdown proceeded without any unscheduled delays. Engine ignition took place at 7:11 a.m.
Spacecraft commander now has made the final guidance alignment. That's the final action to be taken by the crew on board the spacecraft until after the launch. T-minus 30 seconds, T-minus 30 seconds and counting. The 8 first stage engines will ignite at 3.1 seconds in our countdown. They'll be held down while thrust is built up until the 0 mark, at which time we'll get liftoff. We'll be looking for liftoff right at the T0 mark. We passed the 15-second mark in the count. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. We have ignition sequence start. All ignitions are running. All engines running. We have a liftoff. And the second man crew has cleared the tower.
Roll and pitch program, Houston.
Roger, roll and pitch, Skylab, and thrust looks good on all engines.
Al Bean reports. Al Bean reports the automatic maneuver that puts Skylab on the proper course. Altitude 0.7 of a mile. Velocity 1,432 feet per second. 36 seconds. Got a pretty noise to it right now.
Roger that, you're looking real good.
Seconds. 2.5 miles high. 1,700 feet per second. Come down.
Roger, stand by for mode 1 Bravo.
Roll mark. Program complete.
Roger.
Propellant up RCS command.
Roger.
Yeah, I get a great feeling of motion up here, Nick. It really feels like it's moving now.
Roger, PLT and Skylab Houston, your feet wet.
Understand. And we'd like to try that liftoff again. That was great there, Dick.
My turn next.
That's a report from Jack Lousma.
Within a few hours, the astronauts rendezvoused with the orbital workshop.
And GNC reminds us that the same thing happened on 2, that during this phase we did get hot quads, and it was on A, so just keep an eye on it, and so will we.
Roger. Dick, I'm going to take the camera loose, try to handle, see if we can do better, and we'll give some hazard plate shots. Which flight are we on?
Roger, Jack.
Okay, Dick, that half moon in the bottom of the picture is function of something
Roger, we just came to the same conclusion, Jack, and INCO suggests cycling a power TV camera power switch off and then back on again.
You mean S-band aux TV?
That's affirmative. That's affirmative, excuse me.
Correction, we're not getting a picture yet.
Skylab Houston, we got a picture back now. We can see the Earth in the background, and apparently the cycling the switch didn't help, so we'll probably live with what we have.
Well, the old parasol, Dick, is really blowing in the breeze. Looks like about a 10 or 15 knot gale every time the thrusters fire in just a very gentle fly around here.
Roger, we were watching that very thing there.
You can tell that the jets force the parasol up against the shiny surface of the workshop as we fly around, and then it's the recoil from the springs, the fishing rods that spring it back out. We'll try to drift off to the side a little bit, and then maybe we can prevent hitting it.
Roger, CDR, concur with that.
The problem is we're trying to slide around to the front of it, and every time we fire aft thrusters, which move us that direction, it tends to get under the front edge of the sunshade. We'll try to just drift a little bit longer.
Roger, CDR.
We're drifting away the best we can. I'd like to turn a little bit to the left and show it to you better, but every time I start to turn that way, it gives the parasol a flip up at the front.
Roger, CDR. Do what you think is best to avoid as much blowing of the parasol as you can. We'll do without the picture.
Following a fly-around check of the space station and its Mylar solar shield, the men docked their spacecraft with the workshop.
Skylab Houston, we've taken a look at both the CSM and the Swiss. They both look good. You're go for docking. We're about 2 minutes from LOS at Bermuda. We expect to be at Carnarvon at about 8:52, so we'll see you there. Probably at the Carnarvon Pass or Guam following that. I do have some changes for you in the NOCOM section of the entry checklist, so after you get docked and squared away, it's in locker R1. You might get that out, and I'll get that out of the way. So go for docking. We're about a minute and a half from LOS.
Roger.
Okay, we're docked. That went real well. The tunnel pressure integrity check worked fine. We have not removed the hatch yet, and we're having a snack, and then we're going to get after it.
Roger, CDR, and we'd like accept on the computer. We got some CMC servicing to do.
An oxidizer leak in one of the quad thrusters was the only blemish on an otherwise perfect flight. The leak would mean a slight loss in attitude control on the return flight, but at this point, it appeared to be well within backup control capabilities. Leaving the detailed analysis to ground specialists, the crew wasted no time moving into their temporary home.
All three men experienced some dizziness and motion sickness during their first days aboard the space station. The transfer from Earth's gravity to the weightless environment of the Skylab had been accomplished too quickly.
Activation consumed the better part of the first week because not everything went according to plan.
I closed the circuit breaker on that beauty, and it popped open. And so then I turned the switch off and closed the circuit breaker, and then turned the switch back on, and the circuit breaker popped open again. So something's wrong with MOSIP B secondary fan.
To give you a feel where we are at the moment, we're beginning to eat our meal right now. We've had to move extremely slowly to keep from causing any vestibular problems with ourselves. By that, I think both Owen and I have a little bit of stomach awareness, so we tend to be fairly careful how we move. And since we are moving rather slowly, then it's taken a little bit longer than we had planned.
Because of built-in mission flexibility, the delay had little impact on overall scientific gain. The flight plan was adjusted as required while the crew continued to make headway. On mission day 6, a second quad thruster indicated failure. Even so, command module control was still adequate for the return flight. However, the uncertainty of additional failure prompted an urgent decision.
Hey, Al, this is Chris Kraft.
Go ahead, Chris.
As far as the RCS system is concerned, we really can't determine at this particular moment whether we have a generic problem or whether we have some two unique problems with these quads.
Now, just to be prudent, however, we have started the preparation of the vehicle at the Cape on a accelerated basis so that we would have a rescue vehicle available to us should that become necessary. Okay, now, I guess in concluding, I'd like to say that further that we're proceeding here with as if we're going to have a nominal mission. And if you feel like you need any further discussion on this thing, please feel free to call us in any way in which you want to.
None. You just said the right words. We've been hoping you'd say that all day ever since we found out that that was a true problem that we had with our quads this morning. And we agree 100% with what you just announced.
Okay, so be it.
At Kennedy Space Center, a rescue mode of assembly and launch operations was put into effect. An Apollo spacecraft, which could be used as a rescue vehicle, was checked out on an accelerated 24-hour, 7-day-per-week schedule. Skylab was the first manned spaceflight program to have a rescue capability. It called for 2 astronauts to fly a 5-seat spacecraft into Earth orbit, rescue the stranded crew, and return to Earth. The launch vehicle for the rescue operation, a 2-stage Saturn 1B rocket, was erected and checked out under a similar accelerated schedule. While the rescue spaceship was being prepared, NASA and contractor personnel in several areas of the United States ran tests to determine whether the Skylab astronauts could return safely to Earth in the malfunctioning command module. Using an Apollo spacecraft simulator, technicians tested alternate methods of maneuvering the command module. They concluded that the 3 Skylab astronauts could safely fly their present spacecraft back to Earth.
As the mission entered the second week, the crew stepped up the medical protocol, somewhat slighted up to now because of more pressing needs.
We also have a way to measure our heart rate. And this reads out our heart rate, beats per minute, as we're pedaling. Of course, the harder you pedal, the harder your heart has to work, and the better it is for your cardiovascular heart system. While we're pedaling this bicycle during the medical experiment, our breath is analyzed in this metabolic analyzer so that our pulmonary system can be thoroughly evaluated during the period that we're up here. This is used in combination primarily with the lower body negative pressure experiment. The man slides in from the top here. He slides into his waist. Then we pump him down to semi-vacuum. That draws his blood from his head down into his legs. That's a good measure of how well his cardiovascular system is performing over long term in space flight. Of course, that's one of the reasons we're here.
It was also considered important to check the response of the vestibular system, or the little balancing mechanism within the inner ear. And we did this by means of a rotating chair. Now, normally when you sit in this chair and rotate on Earth and move your head, it doesn't take very long before you experience motion sickness. However, up there we noticed that after we were there a few days, it was possible to sit in this chair and rotate almost all day long with no sensation or motion sickness at all.
Food log. CDR, 4 salt packs and 1 strawberry drink.
Other medical data was compiled from an accurate reporting of the daily food and fluid intake. Body waste and food residue were weighed daily, and the wastes were either dried or frozen for return to Earth for analysis. The weight of each crewman was also checked daily, not by conventional scales, but by a device that electronically counts time of oscillations of the subject to determine mass.
The Skylab medical experiments were perhaps one of the most important things we did during the whole Skylab mission. We attempted to take a look at man as he reacted under long-term weightlessness. Whether or not we can extrapolate that to several hundred days, incidentally, it takes something like 400 days for a typical Mars mission, we don't know right now. But it does indicate that we're on the right way to in assuming that man can exist for long times at zero-G.
This is Skylab Control at 11 hours 55 minutes Greenwich Mean Time on mission day 10. Today's entire crew schedule is devoted to the extravehicular activity.
This was the first of 3 scheduled EVAs. The amount of work to be performed would make it the longest.
I don't know. I've got to check now. Do I have any twist above me, Jack? Nope. Okay, now let me see about this.
Erecting a new sunshade over the workshop was their most difficult task. The parasol, deployed from inside by the first crew, had done an adequate job of thermal protection, but temperatures were still high in places, and too, the life of the parasol was questionable. The sunshade would even out workshop temperatures, and it would endure well beyond the final mission.
Everything's going in good up here. They're working at a slow, steady pace. Nobody's tired. So I have a feeling that the last half is going to go a little bit faster. We were the most concerned about this one because we didn't want to lose any parts.
Okay.
The EVA consumed about double the time allotted, but all tasks were successfully performed. The total time outside the workshop was 6.5 hours, a new record for orbital EVA. Temperatures began to fall before the day ended. They eventually stabilized at around 75 degrees, providing the best environment in the workshop since it was launched. The following day, the Apollo telescope mount was put into manned operation, allowing quick and accurate pointing of the telescope array at current solar phenomena.
Now, to begin with, when I switched to the 2 positions called H-alpha, these words stand for hydrogen alpha, and they are called hydrogen because the light that we see comes from light radiated by hydrogen atoms in the sun's atmosphere. Now, this light is in the visible wavelength range, and you can actually see these things, these pictures on the ground as well. They're about the only instruments that we have of that nature. And we use them here because we see much of the fine detail on the sun at these wavelengths radiated by the hydrogen atoms. For example, we can see sunspots. We can see network. We can see filaments. All of these things on the sun in great detail. Now, the next display that I'd like to discuss briefly is a white light coronagraph. Now, this coronagraph also records or images pictures in the visible part of the wavelength. But it has a very unique feature which makes it something that cannot be observed very often from the ground. And this is, it has some occulting discs out in front of the telescope, so that the center of the image, the disk of the sun, is blotted out, and all we see is the very faint light coming in from the solar corona. Now, those of us on the ground can only see this at those very infrequent intervals when we have a total eclipse of the sun. Now up here, we're essentially looking at a total solar eclipse all day long. And we monitor the changes that occur in the corona, and once we tie all of our pre-missions together here in Skylab, we will have monitored the changes that occur in the solar corona over a period of over 5 months. And some of the changes are dramatic indeed. We have, as a matter of fact, recorded some very large transients that occurred in the solar corona. A large bubble of gas was blown outward through the solar corona. It stretched the magnetic field lines out like rubber bands, and finally burst the rubber bands, and the gas continued far on out into the corona and eventually reached the environment of the Earth. Now, when these gas bubbles do reach the environment of the Earth, they cause some very interesting things which we can see, or you can see, on the ground. Aurora are one of the most fascinating things that are produced by the arrival of these clouds of gas and magnetic field disturbances. And when they arrive and perturb the Earth's magnetic field in some way not fully understood.
And we've brought back a number of very fascinating views of these sorts of events.
Dr. Garriott went on to explain instruments that record in the extreme ultraviolet and instruments that provide data in the X-ray wavelengths. And he talked about that interesting phenomena we call solar flares.
Flares, for example, are some of the most outstanding transients. We've had the good fortune to see several of these since we've been up here in the last 4 weeks. And when these events occur, we very quickly go over and train all of our instruments on those flares and begin taking photographs as rapidly as possible in as many wavelengths as is possible. And we hope to better understand what produces these flares, what is the size of the flare, and perhaps better understand the mechanism by which these things are produced.
Okay, rep start, Jack. Tape motion is working. Weather fly, Al. Stand by for auto cal at 3 seconds. Go. 1.
The Earth Resources Package was enabled. Its 6 remote sensing systems put into full operation.
In 39 viewing sessions, 16,000 Earth photos were obtained for use in crop surveys, population growth studies, land use planning, and searching for natural resources.
Okay, we've just been looking. Here's our orbital map. Here's Africa. This has been our orbital path. The Sahel is an area that's about 500 miles in width, extending south from the Sahara. Here's the Sahara, from the Atlantic to the Red Sea. This area right here is under an extreme drought condition now, caused by lack of rain for the last 4 or 5 years, or a minimum of rain for the last 4 or 5 years. It's a 6-nation area, and in that area, several billions of people live. Now, from Skylab, we're not going to be able to make it rain. But we think from Skylab, we can look down with suitable sensors, photographs we actually did just a few moments ago, look down with these sensors and find areas that are not so affected by the drought, that might not be obvious to a man on the ground. We also think we'll be able to determine areas which have high probability of water tables not too distant below them. In other words, find spots that are good for possible digging of wells, for possible planting of crops where other spots nearby aren't so possible. We think this will be possible on a worldwide basis with equipment such as we're using in Skylab and with equipment such as we're using in our unmanned satellite Earth.
Well, I guess we're crossing the northern border of the U.S. right about now. Over Montana. The border over Montana, coming down through North Dakota and then Minnesota. One of our major objectives in Skylab is to look at Earth and its resources. We want to look at its forestry and its agriculture, its freshwater resources, its weather, its pollution, and a number of other resources that are very important to us on the Earth. This is called our Earth Resources Experiment Package. It consists of about 6 experiments with which we look at the Earth, and we spend a lot of time taking data here. This particular instrument is a telescope, and we can see resolution down to 1/4 mile square. For example, we can see a city block with this telescope. Let's take a shot off the coast of Chicago there. Okay, there's a little bit of tracking in Lake Michigan just east of Chicago. We have another battery of experiments also that are associated with Earth resources, and they are these cameras that take actual photographs in different wavelengths of light. And then these photographs then are returned to ground and processed and evaluated. And the purpose, of course, is to learn how to use our resources on Earth more efficiently and more effectively.
Handheld cameras were also unstowed, their lenses aimed at Earth through the wardroom window.
Okay, and we got that storm story. It's got a nice spiral effect, and it just doesn't look very strong yet.
We think we've got the depression, Houston. It looks like it's just becoming, just being born out here in the Gulf. It's quite large, as you can see. It's right now at obvious that you can see the structure and the size of the hurricane. We'll try to keep an eye on it for you on a day-by-day basis, not only where it is, but how it's developing as far as size and intensity is concerned.
We also had several smaller experiments intended to look at the ultraviolet radiation coming from stars throughout the galaxy in which we're in, as well as radiation coming even from other galaxies. And these experiments were extended out the scientific airlock of the Skylab.
The spiders, Anita and Arabella. This was an experiment to find out the structure of the web they would spin in the weightless state.
Spider appeared to adapt relatively well to zero-G. As I recall, the first day or two, she was a little reluctant to do much of anything, but she then started spinning small webs in the corners and then attached a larger size web, similar to one that she's accustomed to spinning on the ground, to those smaller webs which were attached to the corners. And so she was able to improvise quite readily to the weightlessness of space.
Well, this is the home of Arabella, at least the corner of it in which she's decided to spin her web. I've got a close-up lens on here, so I can't show the full box that she's in. It's actually about 3 times the area shown in this view, and she selected this corner in which to spin the web that you see here. She's been spinning these webs now for a little over 2 weeks, almost every night. And I'm not really certain that she changes it every night, which is a usual pattern for webs or for spiders on the ground, as I understand it.
Arabella succeeded in making a perfect web. Photographs of Arabella's web will be compared to webs produced by earthbound spiders.
Some of the corollary science and student experiments were initiated. For example, these minchmog minnows, being set up for observation, appeared to lose orientation in zero-G.
They would usually float with their belly towards the wall, and then after doing that for a while, they may swim in outside loops again. So apparently they can't make up their mind which way is up and down either.
Yes, sir. Good observation.
But strangely enough, their children, recently hatched aboard Skylab, came into the world without ever having to adapt to zero-G.
CDR, we finished doing step 3. We're going to go back and do steps 1, 2, and then 1 again.
Will body motions of crewmen affect attitude and control of a space vehicle? This question was put to the test in a series of crew vehicle disturbance runs.
Okay, they just jumped off the wall, and you can see the excursion rather clearly on the ATM monitor. It was probably an arc minute or so. They're jumping back, and you can see the excursion up and down on the monitor quite clearly.
A force measuring system, which senses loads applied to the workshop, is matched with concurrent control system data to find the answers. The tests will clear up many uncertainties about crew motion effects and will influence the design of spacecraft of tomorrow.
Observers down here trying to get squared away to get some pictures.
In evaluating the requirements for future manned space flights, high priority is placed on a machine that will allow an astronaut to move freely in space. Such a machine is the Astronaut Maneuvering Unit, here being flight tested by Alan Bean.
Now he's going to fly around those ring lockers.
Maneuvering unit is quite reliable, quite easy to fly. As you know, I believe this is me flying it here, and then Jack flew it some. And we wanted to ask Owen to fly it since he had gone through none of the training. And he got in there and flew it just as well as either of us with the minimum of training, and it's just the on-the-job training up there. It kind of gave you a feeling that this sort of a maneuvering unit could be built where pre-flight training would be minimized, and yet you could still do the job you wanted to do outside.
I say we got enough to do it, Al. We got about 800 to 900 pounds, enough to do the baseline maneuver once more in mode direct. Same thing, yeah. Yeah, maybe another vantage point would be nice. I'm ready when you... Wait a minute. Yeah, I'm ready when you are. Let's go. Okay, he's switching to direct mode. He's backing off from the docking station. Rotating to his right, away from the TV camera. Okay. He wants to do it because that's the way he's done it before. He's got nice rotation going and a little translation. Right now he's shooting a little bit below banjo. He's got about half of his rotation, about halfway there. He's going to be in attitude before he gets to the banjo, which is no problem at all. Now he's stabilizing attitude. His feet are just passing about 5 inches above the food lockers. Coming up into the banjo. His toes are about to touch the dome lockers. Toes on dome lockers. Owen Jerry getting us all on television.
The backpack unit was designed to study the feasibility of such equipment for use outside a spacecraft on future missions.
A foot-controlled maneuvering unit was later tested, but in its present configuration, it got rather low marks in performance. The future design that will shuttle astronauts between spacecraft or from spacecraft to satellite will likely be similar to the hand-operated model.
During a second EVA, the astronauts installed new electrical connections outside the station. The connections were part of a gyro package, which the astronauts had brought with them on their trip up to the station. The new gyroscope replaced a faulty component used in the pointing and attitude control systems of the space station.
Jack Lousma would install a new one.
Okay, Bruce, I'm down here looking at WCIU with all these connectors, and I just got the victim loose. And in a few minutes, the good Lord willing and the creek don't rise, we're going to have this hooked up.
The package was installed and placed online. Within minutes, the results were in.
And for the CDR and telemetry, a six-pack is looking good. The gyros are matching each other.
Good news, and now I'm going to power up the CMG again.
The EVA lasted 4.5 hours. All tasks were successfully performed. Productivity was at an all-time high. They were now running well ahead of schedule and even requesting jobs to increase the daily workload. One such task was the behavior of bubbles in zero-G.
And we will try to cause some perturbation to it again. Now you see the oscillations are much less damped, and it exhibits almost all of the three modes of oscillation that you would expect for more or less a ball of liquid like that. You will spin up those oscillations again by just blowing an air jet. Okay, there it's freely floating.
There were also demonstrations of angular momentum, magnetic effects, a Wilberforce pendulum. There was even an attempt to find out about the aerodynamics of a paper airplane without gravity.
Another set of experiments that we have on Skylab is to explore the industrial uses of space. Here before you have an electron beam welding gun. Now it doesn't look like a welding gun that we have on Earth, but it's operated by high intensity or high energy beam of electrons, which will strike metallic material in this chamber, which can be evacuated, and it's capable of melting the metal and welding two pieces together. Additionally, with this chamber and the electron beam gun, we can produce perfect spheres or ball bearings. So grow crystals in here. As you know, perhaps much of metallurgy and crystal growth and the formation of metals is very dependent upon gravity. We believe that we can grow perfect crystals and perfect metal without the presence of gravity, and we're examining that particular phenomenon here in Skylab.
While most of the time was devoted to experimentation, a part of the astronauts' day was spent on the more mundane aspects of living. There were meals to prepare, cleaning, taking out the garbage, equipment repairs, personal hygiene, and always the exercise. Although a few hours away from the routine was rare, it usually found expression in the novelty of zero-G.
Within 3 weeks after the rescue mode was initiated, the rescue vehicle was moved to Pad B of Complex 39, and launch pad preparations were begun. The rescue vehicle was maintained in a launch-ready mode in case serious problems developed aboard the orbiting space station.
By mid-September, it became apparent that the rescue mission would not be flown. Analysis had shown that command module alternate control modes were more than adequate for deorbit, and the condition had remained stable. In addition, contingency plans were defined for the defective quad thrusters in the unlikely event they would be required. It looked like a nominal mission all the way.
By the 40th day of the mission, routine medical checks indicated that the physical condition of the astronauts had stabilized. Erratic heartbeats and blood pressure had become normal, and weight losses changed to slow gains. The crew's physical improvement was at least partially due to a stepped-up program of exercises. But NASA doctors also suspect that the body may gradually adjust to weightlessness by itself. The mental attitude of the astronauts was good throughout the 59 days in space. Their appetite was very good. In fact, the crew consumed more food than was allotted for the second of 3 manned missions aboard Skylab.
Skylab cameras, meanwhile, maintained a steady flow of pictorial data, such as Earth's horizon airglow. These photos will tell scientists about the behavior of ozone and its importance to the thermal balance of the atmosphere. For the science of meteorology, strong weather systems were closely documented, as were these very striking wind convection patterns. From handheld and Earth resources cameras, our planet was photographically documented as never before. The Alps, Washington, Baltimore, the Grand Canyon, the drought area of Africa.
Just today we completed our last pass, as a matter of fact, and there are going to be literally thousands and thousands of films which will be developed and used to evaluate these techniques for the study of our crops, for the study of water resources, mineral deposits, and that sort of thing. So in the area of Earth resources, I think we do have fairly immediate benefits for all of our country and other countries as well.
Owen Garriott will be acting as an assistant to Commander Alan Bean, who will do the actual job of replacing the film and camera assemblies for several of those ATM instruments. Also to bring back in 3 of the sample arrays for experiments that are now deployed outside the workshop.
During their 59 days in space, the astronauts conducted a long series of experiments. Working 12 to 16 hours a day, the men accomplished nearly twice as much scientific work as planned. By mission's end, everything was working so well aboard Skylab that Commander Bean asked for a few days' extension to the flight. His request was denied by Mission Control, and the crew prepared to leave the orbital workshop.
September 25th, mission day 60. And for this mission, time had about expired.
Okay, Skylab, and we've just went around the Mocha here, and you guys are go for undocking. That's undocking, that's correct.
Check it out. We undocked on time, we're moving away. We indicated about 0.3 of a foot per second separation velocity. We're getting ready to run the RCS check.
Very good, Al, and we'll be watching them.
Seems like we're leaving home, Bob.
Say again, Jack.
To beautiful sight at night. We left our spotlight on. It's just like a Christmas tree. Our spotlight is illuminated to white, and we see them stars in the background. It's quite a beautiful thing.
Recovery would be off Southern California by the USS New Orleans.
Skylab, the bird looks super to us. Your go for deorbit and entry.
Good news. We're ready to go ourselves. We'll see you on the ground, I guess. Is this our last comp?
Should be coming up shortly on main chute.
And the frogmen, the swim team, who will have the job of moving in, but right off the bow now of the USS New Orleans, floating down ever so gently, glistening in the sunshine, the command module, the second manned mission of Skylab, those three big orange and white chutes up overhead, slowing down their speed to some 21 miles an hour, and she drops into the choppy Pacific Ocean. And it is a bit choppy. We have winds here of 13 knots out of the north, and we have seas running 8-foot swells and 2-foot wind waves, 8 to 10 feet. And right now,
report from the ship that they have a visual on the bridge of the ship, that the descending spacecraft is visible from the bridge of the ship. Passing through 2,000 feet now, the ship reports.
that astronaut, Alan Bean, Owen Garriott, and Jack Lousma, who have had a tremendous time. And there's Splashdown. Splashdown. She is now in the water.
Spacecraft reported in stable 2 position.
Here from the starboard side, the upper levels of the USS New Orleans, and we can see the parachutes now draping in the water. Everything going just as it was planned. It's amazing.
Feeling good. Man, what an entry. You should have seen that swirl in the fireball there, oh. Every time I looked down, I had to look in because I couldn't read the disk for about 3 or 4 seconds. It was so bright. Man, that was a spectacular entry. I liked all those bangs, too, when the chutes came out and the strobes. Golly. I like the 3 things hitting the water. I like the hitting the water, too. That felt good. I think going over it topped it off. That was the frosting on the cake. You might as well have everything as long as you're going to do it, right? Everything but the port on launch. You only go around once in your life, you ought to do it right. Right. I'd like to do it again.
The ship moving in now to hoist the command module aboard the ship. 520 yards away now, the ship reports. Flight Dynamics reports a time of splashdown as 22 hours, 19 minutes, 54 seconds Greenwich Mean Time.
Hey, what was the max G's? 3.8.
Looks like a thumbs up and a handshake for Dr. Paul Buchanan. That probably would be the hand of Alan Bean that got shaked first. Alan Bean, who is the record holder of time in space. Dr. Buchanan passing in a tape recorder.
Jack Lousma, the first astronaut out. Next out is Owen Garriott. The Skylab astronauts now being moved into the Skylab mobile laboratory. All 3 of the astronauts appear in excellent shape. Report from the ship, Owen Garriott looks just great.
Feeling, I think, was one where your legs feel strong enough and it doesn't feel like it's too heavy to move your body around. But I think your lateral balance is sort of funny. We didn't seem to have much problem with wanting to pitch forward or backwards. It was mostly the sideways correction.
We will be bringing the line down shortly. The three Skylab, three crew members, Al Bean, Owen Garriott, Jack Lousma, are now in the mobile laboratory, going inside the lab at approximately 23 hours, 20 minutes, Greenwich Mean Time. All three walked outside of or stepped out from the command module and walked over to a seated position. All three looked good, Joni in spirits, and are now undergoing their start of their 6-hour physical exam.
It would take a couple of days for the crew to regain their steadiness, a normal part of the readaptive process. Many hours of medical tests would follow in which all data would be within normal limits. Long-term medical effects would take several weeks to analyze. But for now, they felt well. Their spirits were high, and they looked forward to home and family.
I didn't know we had so many friends. I'm glad to see you all here today.
Reunion took place at Houston's Ellington Air Force Base amid welcome home ceremonies. Just as they will for many months to come, the crew attempted to share some of their experiences. Experiences out of which a store of knowledge was gleaned that will shed new light on our troubled planet. And experiences that have served as a proving ground for the next Skylab mission and for our future course in space.
After a rough start with sickness and spacecraft problems, the second manned Skylab mission became one of the most successful scientific space endeavors. The crew had exceeded all scheduled requirements for the mission and accomplished nearly twice as much scientific work as planned. Skylab was fulfilling its objectives, providing reams of data and photos to answer many questions about the sun, the Earth, and of man's ability to live in space for extended periods of time.